Hi, if you're interested in my detailed training videos in course format, do visit my profile on udemy.com. The link to the same is in this video description. If you live in India or willing to pay by Indian rupees for my paid training courses, you also have the option to enroll on /prog.com. The link to the same is also in this video description. Hi, in this video, I will talk about the find command on Linux to search for files in your file system. I will tell you about a wide variety of options that find provides and how to become more efficient in using those options for your specific use case scenarios. There are a wide variety of ways to search for files in a Linux file system today. Either you can use a graphical user interface, find utilities available on your desktop, KDE or GNOME or XFCE, they all have some kind of UI based mechanism to search for files. But if you work on the command line, you might want to look at the automation aspect, and also sometimes you want to work on remote servers where you only have access via SSH. I think the only way you will be able to search is using command line variant of these find tools. Now, there are some other tools like locate and FZF, which I will cover in another video. These are modern tools which are simpler to use than find, and but they don't provide all the options that find utility gives you in terms of the control that you'll have in how you want to search for files and what action you want to apply on those searched files. So let's get started with how to use find command. First of all, find is a standard utility found on not just Linux, but a wide array of Unix variants. You'll find them on FreeBSD, on macOS, on the latest editions of Solaris. It's there in Solaris older versions also. The way it worked was a little different, but the modern variants are all similar in most of the platforms with minute changes in certain options. Okay, so I will talk about how find works on Linux specifically in this training session. So to begin, I'll tell you that find command can be run on Linux without any arguments. If you run find with no arguments, by default, it just lists all the files recursively, files and folders, by the way, recursively in the current directory. So if I run find with no arguments, you can see it provides a lot of files and folders in my system, starting from the current directory. The current directory happens to be my user's home directory at this moment, but you can also run find command with one option to indicate what is the start path to start searching from. For example, I want to look for all files under /temp. I can just do find /temp here. It just lists all the files and folders recursively from /temp. So there are some files where I don't have permissions to them because not all files and folders are owned by the currently logged in user, logged in as user called Chandra. I believe that there are many files in /temp which is not owned by this user account. So that's why you get this error called permission denied. For now, it will ignore these kind of errors. If at all you don't want to see those errors in your output, one option is you can always end your find command with a 2 greater than /dev/null, which will basically redirect the standard error to the null device, which is silencing out the error, right? You're not really interested in any errors that might come up. In such case, you can see only the filtered down version of files that this user can access under /tmp in the entire directory tree. So find without an action will by default print all the paths it searches through, right? So based on the test criteria, I did not provide any test criteria here. I just said start searching from /temp. It just shows all the files that it will locate in /temp directory tree, and the default action is to print them. I remember the days when I was working on Solaris 7, I believe, and some other older variants of Unix, when I used to run find with even test criteria, but I don't provide the action -print explicitly, the find command will just seem to pause while it's churning on the hard drive. Okay, you'll see the hard disk light blinking, and then it comes back to the command prompt. It's like telling a friend of yours or anyone at home around your surrounding to go and search for the keys, and the person just comes back to you, and then says, yeah, I found it. But then you didn't tell that person what to do with it, what to do once you find the keys, right? Because you don't specify that. Normally, they'll come back silently and say it's found. But where is it? No details. So you should be more explicit in telling once you find the keys what to do. So I'll say, go search for keys and get them to me, or tell me where the keys are. So that action is required in traditional versions of Unix. But on Linux, I remember back from the earliest of days I've been using Linux, the minus print was not necessary. So though some people always do this, they put a minus print like this. This is the action. So once you start searching through /temp, what you do with it, you have to print it. You can see the output is same. So minus print is optional on Linux specifically. So if you don't provide minus print, it anyway prints them as the default action, right? But there are many other actions you can actually mention, like you can ask find to delete all those files, or you can also ask find to execute a command on them, and many other actions which I will discuss shortly. But now let's talk about the search path and also some of the test conditions. Well, as I told you, that find command arguments that you pass are broadly categorized as 3 categories. First one is the search path, where you want to start searching from. If you don't provide that, it allows you start searching from the current directory. However, you can also provide other folders of your choice by using find and /temp like this, or find /etc, or find /user local, for example. So you can specify where to start searching from. But after you search, what are you looking for? If you don't specify what you're looking for, it shows up everything. It shows every single file and folder that is traverses in that directory tree. So you want to specify more exactly what do you want to test. And that is done by using the test options. And I should tell you that there are a wide variety of them. But to keep this training video shorter, I hope I don't want to exceed this to 2-3 hour long video. So to keep it shorter, I'm going to focus on some of the important test conditions, but I'll also give you options for others that you can explore. The most primary things that you will search for is based on the file name. So I want to look for a file that has a name, let's say a.txt. Let's assume that. So I wanted to search for that in user local. So if I do a find /usr/local and I use a minus name and provide a.txt, I always recommend you to add the file names in quotes if you can. This is to ensure that the shell does not do any kind of interpolation, right? And this is very important. I will talk about that, what happens if you don't use quotes in a while. But right now I'm not using quotes. This has no issues because there are no special characters being used in the file name. So you couldn't find any file with the name a.txt under user local directory tree. But let me do this with the current directory. If you want to start searching from current directory, you don't have to provide a path. This will work. But some people will explicitly provide a dot here to say start searching from the current directory. But on Linux, if you don't provide the path component and start providing only the test, it will start searching from the current directory, and the default action is to print. So default path is current directory, default action is print, right? Something to know about. So the very basic, you can just use find minus name a.txt. You couldn't find here, but maybe I'll start searching from some other file name. Let's say I want to look for a file called maybe init.h, a header file of a C program. Hopefully it is there somewhere around. I'm just hoping it. Let me just check if it's there. Yeah, you can see that this file called init.h is found under this path all the way here, right? Under code /Linux 6.13.2, I just untarred Linux source code over here, Linux kernel source code, just for test scenario. So you can see that there's a file called init.h down this tree. It's also found in here. It's also found in here. So there's so many places where it's able to find this file called init.h. But now if I want to search for some other file called shed.h, for example, I can use shed.h. You can see that I did not provide the path, so it starts searching from the current directory. But maybe I want to start searching from some other location, maybe in /etc folder. So I'll say find /etc. But this time I want to search for a file based on the name. Maybe I want to call it rc.local. I know such a file exists, so I'm going to find out where it is in /etc. So I'll give minus name rc.local. You can ignore the permission denied, or if you find this a little annoying, I will always redirect all the errors for now to /dev/null. Obviously, etc folder, there are many folders and files which are secured. for normal users access. So you need to have root user permission to access those files or directories. That is the reason why I got this permission denied. So I'm just going to silence out the errors. So I don't really care about folders I don't have access to. So in such case, when I run find /etc minus name rc.local, it's found directly in /etc, right? But maybe I want to look for another file. Let's say I want to look for a file called maybe ld.so.cache. Even that's found in /etc. It tells you it's found in /etc. So you can look for any files down the tree. It'll search for it. So at the very bare minimum, you can provide find what path you want to start searching from, followed by search based on the file name. Provide the name here, and then after which you can perform any action. You don't provide any action. It just prints the path to those files. Remember, though I'm using minus name, it is not necessarily a file name. It can be a folder name also. For example, I can just do a find /minus name local. I'll also put a 2 greater than /null to redirect the standard error here to null, assuming the folders I don't have access to, just ignore them, right? You can see a folder called local, or maybe folder or a file by name local is found in all these locations. These could be files, these could be folders. For example, there's a folder called mnt local, user local. These are folders, definitely. But there's some of them which could be files. We don't know that. Now, I can also couple one more condition here. I'm only interested in a folder by name local, not any regular files or other file types. If you want to search files based on a specific file type, you can also add one more test condition over here, minus type, and add a D for directory, which is a folder, right? So you can just say minus type space D. It'll only look for folders with the name local. You note that I've used two test conditions here. So both test conditions will have to be satisfied in this scenario. So it's like an AND condition. So you should find by name called local, and it must be a directory, right? So the type is specified and the name is specified, and you can see the outcome of this is only list folders by name local. I think it's a smaller subset than the previous one. If you just scroll up, you can see there are more entries here like init ramfs, scripts local, and matjax, some files which is there here. But you can see the number of lines in here is larger, right? But the number of lines here is much, much smaller. One way to verify that is maybe I can do a pipe wc minus l here. Word count, number of lines, right? So there are 12 folders that have a name called local in this directory. That's from the root directory. However, if you're looking for both files and folders and all other file types, I'm going to remove the minus type option here. And now you can see it reports 18, right? So if you want to search for file based on name, you can use minus name switch. Based on type, you can use minus type, D for directory, F for regular file, L for symlink, B for block device file, C for character device file. All the 7 file types it can recognize by those characters. Okay, so I will try to show you some more examples slowly. For now, let's focus on the minus name switch more. Okay, so if at all I do something like say over here, do a find dot current directory minus name, and if I just do a star, okay, maybe what I'll do is I'll create some files here. So I'll do one thing. I'll just do a touch a.txt, touch b.txt, touch c.txt. So there are some files with .txt extension in the current directory. There are a couple of files, right? Now I want to look for all files with .txt extension in the current directory tree. I want to know all the files that end with .txt in the current directory and all the subdirectories. So if I want to do that, I can do a find dot minus name, and you can use a wildcard like this. But here's where the problem lies, right? So when I use a star.txt here, just see what happens. It throws some error. You can see that paths must precede expression b.txt. Possible unquoted pattern for after predicate minus name. Wow, this is smart. In the older versions of find, it did not report the second line. It also gives you a suggestion. So whenever you use wildcards like asterisk, or we call them shell globbing expressions, path name expansions in Bash, for example, like square brackets or asterisk or question mark, it's better to quote the entire file name inside them because you don't want the shell to expand it. What happened here is when you use the star.txt, the shell got this command executed like this. I'm using echo like a debugging way to figure out how a command expansion works. Expansion of all the commands features are done. So the find command is executed this way by the bash shell on my system right now. That's the case with all the bone compatible shells, by the way. So it shows that find dot minus name a.txt b.txt c.txt. This doesn't work. So minus name, you need to pass just one extra argument based on the file name. So to make it work, you need to put this in quotes. So when you use a single quotes or double quotes with the name, you're trying to ensure that the shell does not apply any expansion or even word splitting operations. Your file name also has spaces, you need to quote them, right? So it's always suggested that when you use a minus name switch, use them within quotes. So when I do this now, I run this command without the echo, find in current directory based on file name that end with .txt extension. Now we can see the outcome. It looks for all files that end with the extension .txt. You can see there are there in wide variety of folders here. This includes the ones in the current directory, like you can see the c.txt and a.txt right here, but you can also see a lot of other places where these .txt files exist in the directory tree. Most of them in the Linux kernel source documentation, right? So that is something that you should note. So in summary, if you all want to search for files based on name, the minus name switch can take shell globbing options, which are also called as the path name expansion switches. When I say path name expansion, I guess you can use even square brackets and provide a character class, or you can also use asterisk to indicate match any characters, question mark to match one character, which can be anything, right? Some other examples I can show you is you can use find dot minus name. I'm interested in all files that end with .s, which is assembler files. You'll find a lot of them in the Linux kernel source tree, but I'm just interested to find how many are there or where they are located. So you can just do a find dot minus name, and here you can just use star dot, and maybe I'm interested in dot capital S or small s, right? So when I do this, just report only the .s files. Looks like they all end with a capital S. But maybe I'm interested in only the C sources and header files. You can look up star.c or h. So most of the C files end with .c extension or maybe .h extension for the headers. So you can cherry pick exactly those extensions by using this character class, star.c or star.h. And this is how it works. You should also note that if you're interested to use more complex pattern matching techniques, you can also use something called minus regex, but I will not get into that. I will show you the documentation for it. Now, one of the things that you would need to know is, okay, I know all these options that you told me on the video, but I want to go back and read the documents to explore further. The way you can do that is obviously you can use man find. The man command will show you all the man page for the find command. So when you say man find, the find's help is shown in the manual, and you'll see it's quite elaborate. It provides wide variety of options. The expressions are listed in here. So they have actions, global options, position options, operators. The syntax grammar is fully documented in this manual. And it also tells you about positional options and global options, and you have tests. This is where I was talking about the minus name and so on switches. They fall under this category called tests. So you'll find, for example, so you can see minus regex or minus iregex. Iregex is like regex, but it's case insensitive. You can use minus I name to make it like case insensitive searching. You want to look for files in a very case insensitive manner. Instead of minus name, you can use minus I name as an option, right? So all these are documented in here with a lot of details. Yeah, it's quite elaborate and you can easily get lost into this. It's quite overwhelming. But in my opinion, there's another way to look up the same documentation or find in most Linuxes. If you have the info docs installed on your Linux distribution, I think you can just use a apt install info on your Debian, Ubuntu kind of distros, or DNF install info if you're using maybe the Red Hat variants, or you can use pacman minus capital S info for Arch variants. Different distribution, different package managers, obviously. But once you install the info.doc reader, you can just try running the command info find. This could be a little more organized because when you go through info, all the default options are documented in here, but you can see a menu below. File system traversal options, warning messages, optimization options, debug options, and finally you find something called find expressions. You select find expressions, it tells you about all the list of expressions, and you can look up the index here. And this is where the complete details of all the expressions are shown. You can go through those expressions in here. For example, I want to know how to use minus name switch better. They're all nicely grouped, right? They are nicely grouped here. So if you just look at minus name, I think it's here. It's minus name, base name patterns. So it says test minus name pattern or minus iname pattern. So it tells you that you can do a case sensitive search or case insensitive search based on the file name. So it tells you how to find it with some quick option examples in here. And there's a detailed explanation about it, right? So you can read this document offline, but I'm just going to show you the demo on the variety of ways to use it. Some interesting use case patterns. I told you how to search for a file based on name. Sometimes you want to search file based on some path as a substring. For example, I'm looking for maybe shed slash core.c. Yeah, I know such a folder exists in the Linux kernel source, so I'm trying to use a shortcut here. So there's a directory tree which I have here. My machine, when I run the tree command, you can see there's a, okay, it's going to take some time. Maybe I should have used, it's because I should run /min/tree perhaps. Yeah. The tree is alias to easily, which I'm using as default on my Linux system, but you can see it's a huge directory tree, right? But I want to look for a file under a folder called shed. There's a folder called schedule, that shed slash core.c, but I don't know where it is in the directory tree. So I can do that by using find dot, you can say find dot minus path, and I can provide the subpath, subfolder followed by some subpath here. So I can just use a substring path, right? So I can say find star path. Maybe I'll use shed slash core.c like this. You couldn't find it, but because it's looking for a folder called shed in the current directory now, right? It's trying to do a complete search. So this is where you can use a wildcard. You can use star, an asterisk in the beginning indicating starting from anything, starting from any paths, but ending with shed slash core.c. So this is how you can find a substring match. So you can see that it's found under code slash linux 6.13.2 slash kernel slash shed slash core.c. So this is another interesting option where you want to search for some subdirectory paths in deep down the tree. You can use the minus path, open quotes, single quotes or double quotes, followed by asterisk, followed by the path. This is a convenient feature to look at. And you can also look at files based on not just name, but also based on size. This is a very, very useful feature, especially working on a large directory tree. I know that my current directory is taking up a lot of space. Let's just find out how much space it's taking. I'll just do a du minus sh, disk usage, summary, human readable, current directory. This can take some time. Oh, it's taking 1.9 gigabytes. I don't know which files are very big here. I want to look for all files that is larger than 10 megabytes in my directory tree, my home directory. Is there any file that's more than 10 MB in size? To check that, you can use find. Because I'm going to select current directory, which is my home directory right now, directly I can say minus size. And I can just use plus 10 capital M for indicating megabytes. So when you use the minus size switch, you can search for files based on the file size. Now when you use any of these test conditions, which takes an extra option, which is a number, mostly, you have an option to put a plus or a minus or the number exactly. There are the way it sort of interprets them. I will explain them in a while. But now when I use a find dot, or the dot is ignored here, minus size plus nm, it basically looks for all files that is larger than 10 megabytes. all these files are larger than 10 MB in size. But it'll only tell you the file name. It'll not tell you what size it is. If you want to print the size information also, you can, and this is where you need to use another action. Instead of using the default action, which is to print will just print the path. I'm not interested in the path. I want to know the size. Also, you can use a minus printf. When you use a minus printf switch, you can use interesting format specifiers. You can print in any format you want. For example, I can just print, I can just say, I can just provide maybe file %p like this. Let me show you what it does. And I also add a /n, till you get a new line. You can see that whatever string you had it here, that string is printed. So I can put any string. For example, I can just put printf, let's say found /n. Or you can use printf found, don't put a /n. This is what will happen. Printf found space. What do you see? Or printf, maybe I can use file %p. The %p format specifier will substitute with the path that match the search criteria. Every path, right? Which is search for and match the criteria. It prints the profile path. And I want to add a new line, so it'll be more convenient when I do this. If you don't add a new line, it'll look a little cluttered, as you can see. Not very useful, right? So if you want to add a new line, you put a /n here. This follows this C programming, C style, \escape sequences, and also a variety of format specifiers which are find specific, right? For example, the %p is substituted with the path to the file that is found, followed by a new line here. I can see it lists all the files. But no, that's not what I want. I get anyway by print, but I want to also print maybe the size of the file. This is where I can also print the size percentages. You can see the size is printed. By the way, the size is printed in bytes, unfortunately. I'm not sure if there's an option to make it human readable. We can look up the options in here. I'll show you how to find that out. One way is you can go to the man page or the info docs. Let me use the man page for now and search for minus size in the man document. I use a / to search. I'm using most as a pager, but your default man pages might use less as a pager. You can use any one of them. / and provide a search. I'll use minus size here. Yeah, the size option is shown right here. You can see. 1 minute. It's below. Search for one more occurrence. Yeah, I think it's interesting. You can also use M here. It does take this option. So you can use minus. Okay, not minus size. Sizes. Searching based on size. That's what it is. But I want to print it in printf. Let's use minus printf here. You can use minus printf. You can see the printf format. All these are format options that are supported by printf. I only showed you %p. I showed you %s as an example, but you can provide a wide variety of stat options. That is, once you find a file, you can print the file size, file ownership, file permissions, number of links, file type, file timestamps. All of this information can be printed by using printf. So the wide variety of options are shown here, which can be used in the printf string. It has format specifiers, like you can print timestamp in a wide variety of ways, amount of disk space used, birth time, last address change, and all these details. But let me look at the %s here. Yeah, file size in bytes. I don't think there's an option to print file size in, okay, file sparseness. This is calculated as block size into st blocks, the exact value. Okay, ordinary file. No, I don't think this is going to be useful to show it to you in the block sizeness. That's it. So I don't think there's an option. No, there is no easy option to print it in that form. Okay. Okay, I think it prints in bytes, so we need to convert it separately, right? But anyways, it's convenient, especially from the perspective of automation. So mostly if you want to find out the total size of all the files, that is more than 10 MB. Total size of all the files is more than 10 MB in my current directory tree. You can do this using find with a little bit of shell gimmicks, which I will demonstrate right now. So for example, if I just do this now, I'll only print the size. Okay, I'm not interested in the path. I'll only print the size like this. If I /n, only the size of these files are printed. All of the files has more than 10 MB. I want to find the total size. I guess you know how to do it. One option is you can just use plus like this, and don't add /n at this moment. This becomes more like an arithmetic expression, and then you can actually use tools like expr and calculate it. For example, you can use expr, output of find command, with all the sizes printed for every file that is greater than 10 MB in the current directory tree, followed by add a 0, because that after the last plus, you need to add one more number. That's why I'm using expr. Run this command, followed by a 0. So it'll be, this expression will change like this. If I put a echo over here, the final expression is computed this way. So I'm just going to run it. Yeah, by the way, you can also use BC, or you can, you're adventurous, you can also use the bash arithmetic expansion to do all these things. So just let me run expr like this, and you can see the output. Reports in bytes. You probably want to convert it to maybe megabytes. I think all you need to do is just use another parenthesis here. I think you need a / escape parenthesis when you use expr directly in the shell, and close this and divide it by maybe one more parenthesis, 1024 into 1024. I need a / escape even the asterisk here because it's a wildcard expansion that must be escaped in shell. I know it got a little weird, but basically it's like you took the size divided by 1 megabytes, right? That 1 MIB, that is megabytes. So this will report in MB. So 266 MB worth size is used by files more than 10 MB. So if it's 1.9 gigabyte, I think there are many smaller files than 10 MB which totally accumulate to the disk usage close to 1.9 gigabyte. So anyways, I just detoured. I showed you how you can use it in automation and all that. Come back over here. If not, I use a size. I can also provide certain interesting options, like say, I want to look for all files that is below 100 bytes. I want to look for all files that is below 100 bytes. If I want to look for all files that's below 100 bytes, one thing I can do is if I just use +100, I don't provide the suffix. If I don't provide the suffix, the size is represented in blocks, by the way. That's what is the default in find. If you want to search based on bytes, add a suffix as B. B for bytes, K for kibibytes, M for megabytes, G for gigabytes, right? You can just say bytes, KB, MB, GB, whatever format you want to use. And if I use -printf, this time I want to print only the file name, not the full path, and the size. First, I'll put the size here. I can also format the size nicely by using, I want to format the size to maybe, it's only 100 bytes. So maybe I think 3D should be good enough. So I'll just use 3D. %3D will sort of pad it correctly to up to 3 bytes. It'll right justify the size automatically. And 3S, okay, not D. Yes, in D is for decimal in C programming, but size padded with 3 spaces, right? Right justified, followed by the name. I'll use %n here. I hope n is name. Let me just verify. Followed by a /n. No, n is number of links apparently. So maybe it's a capital N perhaps. No, it's not capital N. If the %format specifier is not understood, it will just print that as is. So if you want to get only the file name part of it, I think there's a way to get that. You look at the printf. So you have the %sign, you have so many options here, right? So it's difficult for us to remember everything. I think it's %f if I'm not wrong. %f right here. You can see this. Print the base name, the file's name without the leading with any leading directories removed. Only the last element, not the full path, only the last component of the file name. It's called the base name, right? So let me just use that now. I think it's use %f. The moment I say +100 bytes, actually it prints all files that is greater than 100 bytes. I want to print all the files that is below 100 bytes. How do you do that? You put a minus. The moment you put a -100b, it only tries to search for files whose size is below 100 bytes. This even includes a 0 byte file. Okay, so I'm going to show you right here now. But then when this didn't work, I think the B switch is not for bytes. Let me just verify that right here with a size option. I might be wrong. So we just go back to the size option, which is here on top. It's here. Oh yeah, B is for 512 byte blocks. This is a default if no suffix is used. Adding B is pointless. You have to use C for bytes, not B, C. I make this mistake quite often. Sorry about that. So this B is for 512 byte blocks. It says how many blocks the file is taking, right? If you don't provide any argument, it takes the default as number of blocks, size in number of blocks. So if you look for it in bytes, put a C at the end. You can also use W for 2-byte words, or K for kibibytes, M for mebibytes, and G for GB right? Which is the numbers represented in here, right? So let me just try to use in with C option here. -100C. All files below 100 bytes is what is printed. So all of these are files that are below 100 bytes. Sometimes you want to look for files which are empty, files which are 0 bytes in size, and maybe also folders which are empty. Empty folders are folders with nothing inside them, right? So you want to look for empty directories and empty files. For that, the convenient switch, you can either use directly 0 like this will work. But the more convenient switch is, instead of using find minus size 0, you could use find minus empty rather, which is more convenient to use. This will also report folders which are empty, because folders do take up some size. If you use minus size 0, these empty folders are not reported. That's something to note, because even an empty folder takes up about 4 kilobyte on my file system. So size 0 doesn't really help. So we're looking for empty files and empty folders. It is suggested that you use minus empty as the test condition. So you can either use minus size, specify the size. If you want to look for a file of an exact size, I know there's a file that's about exactly 1 KB, right? So for that, you can use find minus size. Just say 1K. Remember, it's a small k here, small c, small k, but for mega and giga, or it's actually maybe and GB rather, you need to use the capital M and capital G, right? So something to note is there in the man page. So this reports all files whose size is exactly 1 KB, but is it the correct thing? No, it didn't really work, is it? So for size, you need to either provide minus or plus, only then makes sense. Otherwise, I think it prints everything which is within 1 KB. You don't provide the minus switch, is within 1 KB. You can see every file here is below 1 KB. Is there one of them is like 1001, but it's still below 1 KB bytes. 1 KB bytes is 1024 bytes, right? So that's how it is reported. So if at all you want to look for size exactly, I think there's no option. You need to provide either plus or minus to be more specific here. Everything about 1 kilobyte or everything below 1 kilobyte, right? Or if you're looking for empty file, you just use find dot or find minus empty if you want to look for current directory. Let's say for now I'll look for some other folder. I want to look for all empty files under /etc. Empty files and empty folders under /etc. To do that, I can do the same thing. I can do find /etc minus empty. I think that's it. Okay. I can print or printf. So but for now, it'll just print all the files and folders which are empty in nature. So if at all I want to verify them, all these folders could look empty. Like let's look at the last one, /etc init ramfs tools const.d in my machine. So in here, you just look up /etc /init ramfs tools /const.d. This folder is empty. I mean, it'll only have a dot and dot dot. If you even do a ls-a, I don't think there are any dot files, any other dot files other than dot and dot dot, right? By the way, the ls command I'm using is alias to a modern tool called EZA, so EZA. So that's a more modern replacement for ls, which provides all these icons and other things. But if you want to, if all I want to use a real GNU Corridors ls command, the way I can do that is 1 minute, yeah, /bin/ls. You can see you will see a dot and dot dot. This is an empty folder, right? So it reports all the empty files and empty folders. If you're only interested in looking up empty files alone, not empty folders, the way you do that is also add a switch to the find command. Find slash minus empty minus type B. So it will only look for empty folders this time. You can ignore all the permission denied folders because they don't have permission to certain folders, but there are a variety of folders which are actually empty in /etc folder right now. But I'm interested in only the empty files. For that, I can use find /etc under /etc minus empty minus type F. It only looks for regular files which are empty. Now coming to the file type. I show you, if at all I want to find based on file type, the most common file types people look for is folders, that's directories. That's you can use with a minus type D. If you want to look for regular files specifically, use minus type small f. If you're looking for a symlink, you can use minus type small l. So you can do a find dot minus type l. Actually, a dot is not really required. It'll anyway do it in the current directory, even if you don't mention the start path. All of these are symbolic links available on my environment here. I think you can also print you can read link and print where they point to. I hope there's a way to do that. If you look at the printf options again, it shows all these options. There should be another option that will show you files inode number, starting point where the file is found, amount of displays, object of the symlink. Yeah, minus small l, percentage l, right, in printf. So I'll just show you that. For example, I know all these are symlinks, but where do they point to? Which files they represent? To know that, you can use find type l, locate all files in the directory which are symlinks, but I want to use printf this time. And use percentage p, actual path that's found, and where do they point to? And use an arrow mark here, right? I put a hyphen greater than and followed by percentage small l, followed by a slash n. It shows all these are symlinks, and it tells you which particular file or folder that they are pointing to, right? So which locations they are pointing to is also being reported here. For example, you can see I have set up a virtual environment, I believe. So I think in virtual environment bin Python 3.11 is pointing to Python, and Python 3 is pointing to Python, and Python is pointing to user bin Python. You can see that, right? There are symlinks to symlinks to symlinks. So all these are being shown here, right? So you can get complete details on how you want to control. In fact, in the early days, I remember when I was using find, you do this, right? So before I became a master in bash scripting, that's like 20 years ago, okay? 20 years ago, 25 years, I think, back in 2000 timeframe. Those days when I was using find command, I was still not a master of bash scripting. I was just using shell scripts for basic things. For simple automation, I used to create temporary scripts. And what I used to do is, maybe I want to, let's say, perform some operations on all these files. So what I normally do is I used to use printf, and I can just maybe use read link like this. Read link and percentage p slash. This actually read link is a command. So I'm just generating the output of find, which happens to be some kind of command, which I can pipe it to a script. I mean, I can store it to a script, or I can do a maybe greater than t.sh and then run t.sh. You can do sht.sh like this. Can be done in this kind of automation. You can do that, right? But if you know more advanced scripting, you can avoid creating all these temporary scripts rather, generated scripts which you want to run by using proper pipelines and using other tools. So it's possible to do that. In fact, this kind of option can be done in a more simpler way by using the -exec switch or with exams, which I will discuss next in a while. So for now, I just told you how to find files based on type. Remember, I talked about regular file, directories, symlinks. But for regular files, use F, minus type F. For symlinks, use L. For directories, use D as an option of type. But what about other files? The other files are special files. You can look for a pipe by using a P. I can check whether there are any pipes available on any folders. Let me just check here. just do a find slash minus type p. Look for all the name pipes. So, okay, a lot of permission denied. I'll ignore all these permission denied errors by 2 greater than slash div slash null. Yeah, there are so many name pipes or FIFO files in different folders that you can see here, right, on my system. If you're looking for socket files, which is also another kind of, IPC file, Unix domain socket, you can also use minus type S here. All of these are socket files located in my file system. So remember, I use a slash there in the beginning, which means it's absolute path starting from the beginning. It searches the entire file system. Remember, this will also search through every single mount points, right? There are special global options in find where you can control find to indicate, oh, don't search through mounted file systems. Okay, so other mounted file systems don't want to search, you have options to stop find from doing it. I'll show you those options in a while, but otherwise it's going to do a full scan search throughout the file system, including all other mount points. So these are all the socket files located on this file system. If you're looking for maybe device files like character device file or block device file, you can use minus type B for block devices. I guess in an official Linux system these days, you'll find all of them in under slash dev folder, largely, right? You can see it. Oh, there is a block device file that is not in slash dev. See that? So there's a block device file in slash run systemd inaccessible blk. It's an interesting nugget, right? You can find that, but you can see a lot of them are in slash dev folder, all these block devices, or even you can look for character devices pretty much the same way. Oh, there are a couple of character devices found outside dev directory, and a lot of them under slash mnt. I think I mounted another file system in there. So you can see many places, right? Most of them are in slash dev folders. So this is how you can look for files based on the file type. So to summarize, I so far talked about searching files based on the file name, where you can use the path name expansion, that's shell wildcards or globbing support like star.txt and so on. I told you how to search for files based on file size. I told you how to search for files based on the file type. You can also search for files based on, okay, I told you how to search for files based on size also. I created a separate video to search for files based on the timestamp. Rather than spending more time on it, I recommend you to go and watch that video. Just look up in my playlists for Linux command line playlist. You'll find a specific video on that. That was done like 2 or 3 years ago before I made this video. Anyways, so that has, in fact, that one of the video had the highest hits on my YouTube. I realized that most people are figuring out how to search for files. That's why I made this video now lately. Anyways, so coming back, I should also tell you about find with other options. Other test options I can look for is sometimes if you're dealing with hard links. Hard links are, in a way, I'll not say deprecated, but not commonly used on Linux environments today. So hard links are a legacy feature found on traditional Unixes. In the early days, you could create a hard link to a regular file, and you can access from a different path in the same file system, of course. Today, all use case of hard links, they have sort of deprecated it unofficially, and they're being replaced with symlinks. The problem with hard link is this. If not, I try to delete a file, the file space will be reclaimed, can be reclaimed, only when you delete all the hard links to that given file. So let's assume that you have a malicious user in a multi-tenancy system of Linux or any Unix. One of these users has downloaded a very big file, maybe a gigabyte worth file, couple of gigabytes in size. And that person has created about hundreds or thousands of hard links all across the directory tree, wherever that user has access to create files. He created many hard links. Let's say he or she's created many hard links to that file. To reclaim the space, just deleting the original file that was there is not sufficient. You need to make sure that all the links to the file is deleted. How do I find that out? Well, the traditional way to do that is by looking up the inode number and then searching for files based on inode. Let me just show you an example here. So let's say that I'm going to create, let me just create a hard link to one of these files here. I'll just do ls-l here. Okay, I'll use the /bin/ls-l this time. Number of links is not shown by my ls alias that is running here. So all of these files have one link. You can see this. You can ignore the directories. This second field is number of hard links to a regular file. But if it's a directory, it will just indicate how many subdirectories exist in the directory at that level, right? Not in the entire tree, but at that level. So this code has about 11 folders underneath it. And documents has 2 folders and downloads has 2 folders. Every folder, every directory will have at least 2 entries inside them, dot and dot dot. These are technically both are empty folders. Not empty. I mean, there are no other subfolders. They're only dot and dot dot. That's why they report as 2. But for files, you can see it shows us 1. That means there are only 1 link to that file, 1 hard link. I'm going to create a couple of hard links now. So one way to do that is by using ln command. I'll say lna.txt and I'll just say maybe /a1.txt. I'll say lna.txt and maybe I'll just create a /python/a2.txt. lna.txt. And this time I'll add in downloads/a3.txt. Now, one of the things about, or rather I would say annoyance for Linux administrators especially, is this. There's a file here, and I don't know, okay, /bin/ls -l over here. There's a file called a.txt, and you have about 4 links to it. One link is a.txt. There's one link to that inode record in the inode table. But there are 4 of them. One you figure out here. But what about the other 3? If you are not the person who created those links, you will not know that, right? So if you are a systems administrator and some other user has created a file and the file has got about 100 links, 100 plus links here, or even 1,000 plus links, where are they? They can be anywhere in the current file system where the user has access to create files, right? And that is a problem. How do you search for it? There are 2 ways to search it. The low level way, or the legacy way of doing it, is find out the inode number of this file by using ls -li. The inode number is reported. Once you know the inode number, you could use find dot is current directory, not required in Linux. I'm going to ignore it. -inode. It's inode number, and then provide this number here. And now when you run this, it shows all the files that has that inode number. So you can see all the 4 entries here: a2.txt, a1.txt, a.txt, download/a3.txt. So all these are the paths that you could locate. It's a more convenient way. If you know a file and you believe that the number of links to the file is more than 1, and you want to know what are the other hard links to that file in that file system, one way to do that is you can do a find -same file. By the way, it will apply in the current directory. I'm not using dot. That's a default, right? Dot is a default, which is a current directory. So find -same file. And if you do a a.txt here, it reports the same thing. So you don't have to run 2 commands. You don't have to figure out what is the inode number first and get the inode number and hard code it here. Just show me all other links to this file, all other hard links to the file. Remember, symlinks are never a problem. You delete this file, all the symlinks to this file become broken links. The file size is reclaimed. So if the file is like a 10 gigabyte file and you're running short of disk space, you delete this file, you have 10 gigabytes of disk space available now, right? But if it's a hard link, you have to delete all links to this file. Every link to this file must be deleted to reclaim that disk space of this file. So that's why this command is useful. The next obvious command people look for is, okay, I know these parts, I want to delete them. The earlier days, what people did was, you could run find -same file, a.txt, -exec, rm, open close curly brace, / semicolon. Hang in there, I'll talk about this option a little later. But you don't have to run this. You don't have to run this. If your operation is to delete, your action, I would say, if your action is to delete a file rather than just printing it, you can actually use -delete. This will delete all of the files that are the same as a.txt, and that includes even a.txt. delete a.txt and all other hard links to a.txt from the current directory. This is a convenient way to do this. So because I'm using the test option, the test operation is to say same file a.txt, and based on that file that's found, based on the records that is found, run a delete action on it. So this will delete all the files that has the same link as a.txt, and you can see that a.txt is gone. You won't find this in the download folder or code folders. If you just go to code, you won't find that a1.txt existing anymore, which I created earlier, or even in Python folder, you'll not find a2.txt or so on. So all these links are deleted. To verify, you can do a find dot. There's no way to use minus same file. So let me try to use minus inum, and it was 1451063. No, this is quite convenient. You can also use it in a wide variety of ways. For example, I want to delete all files whose size is greater than 10 megabytes. If you want to do that, you can use find. I can just say dot current directory. Again, this is optional. Sometimes I use it, sometimes I don't. If you don't use it, know that it will operate on the current directory. And you can use minus size, anything above 10 megabyte, minus delete. And yes, use these kind of operations or actions with caution, because you delete a file, there's no undo, right? Assuming that you're not snapshotting your file system. So that's something that you should be aware of. So this will delete all files which is greater than 10 megabytes. I'm going to anyway do that. So none of the files are critical on my system right now. It's a test machine. It's a test Raspberry Pi board rather. I delete all the files. Now if you look for any files that's greater than 10 megabytes, you'll not find any of them. It's blank. Let me look up all files that's greater than 1 MB. Oh, there are many files that's greater than 1 MB. Let's say I want to delete all these files too. But this time, I want to print and also delete. So the way you do that is you can use minus print, minus delete. Remember, you can use multiple actions as long as they are not conflicting. Okay. So print is safe to use. You can use print it and also delete it. This will print all the files and also delete it. So after you run this now, run this one more time. It's not able to find any file that is greater than 1 megabyte. Remember, my disk space was reported as 1.9 gigabyte now. Let me see what it is now for my current directory, that is disk usage. Oh, it's still 1.4 gigabyte. There are many small files that add up to this 1.4 gigs, right? Anyways, so coming back. So I told you how you can perform actions based on test criteria, right? So I told you how you can search for a file based on name, based on size, based on type, based on the inode number, and based on same file option. Right? All these are some interesting search criteria. And the next thing is obviously based on timestamp. This is very useful. I cover this in another video, but I'll just give you a quick summary of it. I'll talk about only modification timestamp, which is most common. I want to know what files have been modified in a folder in the last 1 day. And to do that, you can use find, let's say /etc. I want to see all files in under /etc folder that has been modified in the last 1 day. I can use minus m time plus, I can say within 1 day. To say within 1 day, put a -1. So all these files, you can ignore all those permission denied again. I'll put a 2 greater than /del/null. So all these files have been modified in the last 1 day, the last 24 hours, right? So remember, it takes a 24-hour timeline. But if you don't want to take a 24-hour timeline, you want to take a day start. The day will start at 5:30 a.m., I guess, right? So if you want to look at any files that's being modified since 5:30 a.m. Today, so I think it's now in the second day, 2:20 a.m. So it's going to look at 5:30 a.m. We are not reached there anyway. So if you look for that, then you can use minus day start. It's the same, I think. I don't see much of difference in here. Well, not much of a difference, but you will see some differences after I try it out at maybe 6 a.m. or 7 a.m. in the morning. So if you don't use minus day start, it's going to take the last 24-hour timeline. But maybe I'm not interested in 24-hour timeline, in day timeline. I want to look for in minutes. I can use minus m min here. Show me all the files that's modified in the last 1 minute. Minus m min. 1 minute now files are modified. Let's look up in the last 30 minutes. Yeah, looks like there is a file called /etc fake hardware clock.data. There should be some service running in the background, which has sort of updated this file. That's what you can see here. You can also print the timestamp if you want to. What is a modification timestamp? As usual, by using minus printf. This time we use %p, but I also tried to print the timestamp. To print the timestamp, I think you can use a wide variety of options again here. Let me just look up the man page again. So if you look at the printf option, you have all of these fields for time. Last access time, I think %m is last modified time, I guess. Yeah, no, it's permission bits. Yeah, its last modification time is %t, as you can see in CTime format. So I'll just print that. If you want to get only the hours, minutes, seconds, and all that, you can use %A and provide the strf time format, which is fairly advanced. You can just look into it, but this is more convenient sometimes. So you can use %p followed by %t/n. Okay, I'll ignore all the files I don't have permissions to. You can see that this file was modified exactly about a couple of minutes ago. 2:17. Right now it is reporting as 2:22 a.m. my clock. So you can see it's just modified a few minutes ago. So you can actually find out files based on these kind of search criteria based on file timestamps. Remember, the -m time, -m min is for searching for files based on modification timestamp. But your file system also stores access time. Then you can use -a time or -a min, last access time. Or you can also look up based on change time by using -c min or -c time. I would have covered that in another video, so I'll not go deep into this right now. So this is the basics of using search criteria based on timestamp. And you can also search for files based on file ownership, which is sometimes very useful if you are working as a systems administrator in a multi-tenancy system. I want to know all files that is owned by a specific user. Let's say maybe want to look for all files owned by a user by name Alice. So I hope that account is there on my system. I'm just going to check that anyways. So in my root directory, on my root directory, I'll do a -user Alice. It reports all the files owned by Alice. Okay, let me just try to redirect all the errors to /2/null. Strange. I think there's a folder called Bob that's owned by Alice. Actually, that's a different file system. There's another. Okay, it's from another file system. Actually, I've used it as another pen drive. I've connected on my USB port, which used account names with UID is mapped differently. So what is Alice in this particular Raspberry Pi board is actually Bob in another Raspberry Pi board, where user accounts are created in a different order. That's why it's reported this way, but it is shown as Alice here. So this is how you find out files owned by user. If you don't have permissions to descend to a directory, you will not be able to find details in it. You will have reported errors. So I'll run with sudo command over here, which will run as root user. You will see more details. See, all these are owned by Alice, all these files, right? So you can actually find out files owned by a specific user. You can also use -group, find files owned by a group. For example, I want to know what files are owned by a group by name Shadow. I know that such a group exists under /etc, let's say. So I'm just going to do a sudo find. I'm going to run as root user this time. Under /etc, look for all the files owned by the group Shadow. etc shadow, etc shadow hyphen, g shadow hyphen. All these files are owned by a group called Shadow. We can verify that by looking up ls-l. Sol under /etc. So I'll use ls-l. Let me use /bin/ls this time. /l /etc/s. I'll use maybe star shadow. You can see the group name is Shadow, as you can see here. If at all, one more administrator friendly option is this. Many times when you delete a user account, the user's home directory might be deleted if you use a command called userdel -r. So apart from deleting the account, you can also get rid of the user's home directory, the home folder. But if you have given the user the permissions to create files outside the home directory, the files and folders created by the user will not be deleted because there's no way to track them, right? There's no centralized repository or anything on Linux to figure out where all the user's files are stored. So just gets rid of the user account, maybe local accounts from etc password and shadow, and also removes the user's home directory. That's what it does at the best. But maybe the user created some files under /temp and /var/run or any folder where the user has write access, let's assume. And once a user account is deleted, you need to get rid of those files too. Why is that crucial? This can open up security concerns if you create a new user account after that. For example, let's assume I create a new user account. Every user account that you create on a Unix system, including Linux, a local account especially, will be designated with a unique UID for that username. For example, if you run the ID command here, you can see the ID for Chandra is 1000, right? It's showed up as 1000 here. That is the user account, the username, user ID for this particular user. Now, if at all I delete this user, I remove this user account called Chandra. Now, if I try to create a new user account, there's a possibility that the new user account will be reassigned with this UID. Chances are there. This happens especially if the user account that you deleted was a last UID user. For example, on a local system, if you have etc password here, I'm using batcat instead of cat, so it looks polarized. You can see the last user account that I have is Tux. The UID has got the highest number amongst all of the users, right? Like I have 1001 for Chandrasekhar, 100 and glances 107. I'm not sure how it's created here. 1002, 1003, 1004, 1005. There's 1006 here. If I delete this account, right, this UID number is available, which means that after that, if I create a new user account, that user will be assigned with UID number 1006. Now there's a problem with that. The problem is, if any files are owned earlier by a user named Tux, you deleted the account. Maybe you create a new account, maybe an account called Rick or any name, Dave or anybody. Magically, all the files that were owned by Tux on this file system will now be owned by the new user account because that user has got this new UID reassigned. And that is a security concern. So sometimes when you get rid of a user, when you delete a user account, you have to be extra sure that no stale files of that user is there on your file system. I have done this for an experiment for this particular video where I had created a user, created some files under /temp, then deleted the user account. So the user which I created had a UID 1007. We don't know what the username is right now, but I'll show you. The files of that user exists. You'll find them in /temp. You go to /temp here. Maybe it's called this folder, hopefully. Let me just find out. Yeah, you can see this, scripts. Do you see a number instead of a username here? Whenever you see a number being reported instead of a username in the ls-l, this is an indication that this folder or this file was owned by a user whose account is no longer there. At least locally, it is not resolved, right? So this is a no owner kind of a folder who has no owner at this moment. To find out who paths to files and folders like these, you can actually use the command. I'll use sudo now. Find / from a root directory. Find all files which have no user ownership. That is files that are owned by a UID which does not have a designated username in the local password file on my system. So when I run this now, it does a full scan on my file system, so it's going to take some time. There are many files and folders, not just this. So you can see all these files and folders. You can see that /temp/scripts is reported. But interestingly, you can also see /mnt var lib postgresql. The reason is because that is a mounted file system of another pen drive, which are supposed to be a boot pen drive of another Raspberry Pi board. The account number assignment for PostgreSQL, I think I installed PostgreSQL on that particular Raspberry Pi, but in this it is not installed. Maybe that could be a reason, right? So that means you have UIDs, but no user account locally on the system to verify that. So if you just even check this, for example, just like the, let's take this one and say this particular entry. I'll use /bin/ls over here, -l, followed by this particular path. No, I think the switches don't work as expected. I need to find out the shortcut in item. Sorry about this. And I do a okay. I think I need to configure my tmux with item. There are some issues. I just switched to item in my macOS today. So yeah, let me just do this manually. Okay. Search. Search. /mnt/lab/lib/postgres/sql. I'll just show you this particular folder itself. I use ls-ld to list the directory as if it's a file. You can see that UID and GID is reported here, not the username and group. So that's the reason why when you use a no user option, minus no user option, these folders reported. That means these are files or folders owned by users who don't have a user account on your local computer. Okay, these are like nobody owns this in this computer right now. So that's what it is. So you can find files like these by using find/minus no user. Similar to minus no user, you can also use minus no group to search for files that's not owned by any group. All right. So I think I spilled over this video beyond an hour. The last thing I'll talk about, I think I'll make a part 2 of this video where I'll go a little more level deep. But now, one more thing, one more option I should tell you is the action part. So I told you various ways to search. There are different ways. You can search based on all kinds of stat information, right? So the next thing I should tell you is performing actions. So far I told you about print and printf. You can print, you can also use printf. But there's also another action called exec. How to use exec option to execute any custom scripts or custom command on the file that you search. Let me show you how to do that. For example, if at all I do a find dot minus, I'll just do a name star.txt. It will search for all the files with .txt extension. I can also use a -exec and then do cat that file. I want to concatenate all the text file together, all the text files in the directory together. I can use cat followed by, I can use open close curly brace. This is interesting. The -exec command, that action will let you perform anything. It can be executing rm command, which is not very useful. You can use -delete instead in modern find command. In early days, you use -exec rm -f and all that, right? But you don't have to do that now. You can use cat command. You can use cp command if you want to, right? You can use a wide variety of commands, right? You can copy all these files into one location. Sometimes some of these files with the same name will be overwritten. One will overwrite the other. That can also happen. And but I'll use cat at this moment. Okay, I'll use cat. But when you put an open close curly brace here, this will be substituted with the path that is matched the test criteria. So cat, the open close curly brace will take the substitution of the path. And then you can put a / semicolon. This is very, very important. This is how you indicate that the command has completed, right? Because after that, you can put a -print also if you want to. You can add more actions after that. So to say that this command is completed, you say -exec, whatever valid Linux or Unix command that you want to use. But in that command, if the command takes a file name as an argument, you want to substitute the path that is searched to that particular argument. You put an open close curly braces, but to end the command, you need to end with a / semicolon. Some people ask me why you need / semicolon. Technically, you need to pass semicolon, but the shell expands semicolon as a command delimiter. It separates multiple commands in a command pipeline with semicolon, right? You can do this in your shell. You can actually run this like, date semicolon, uname semicolon, who am I or something. So you can have command pipelines like these separated by semicolon. The shell is expanding the semicolon to indicate that first command, second command, third command. But when you're using find command to perform this kind of operation, you have to pass a semicolon as is to find command without the shell interpolation. And that's the reason you backslash escape to tell the shell not to interpolate semicolon. So if you do it without that, so you'll get an error. I'll just show you. Do a cat, open close curly brace, you put a semicolon like this, you get an error. So make sure that you put a backslash semicolon at the end. All of these files are concatenated together. But maybe what I can do is I can concatenate them and say greater than, and you can say one big file. To be convenient. Remember, instead of cat command, you can use cp command, or you can do anything. Yeah, because I'm searching for the file. And this file that I'm writing to is also part of the search. It can get a little recursive. That's why it shows input file is also output file, right? It gives you this kind of a warning. The cat command is trying to write itself to itself. So that won't work. But having said that, most of the files are concatenated in here. You can see this, right? But to understand how this exec works, remember, for every single entry that you pass that matches that particular search criteria, cat command is executed. Which means if for all this find is able to locate 10,000 files, 10,000 times cat command is invoked. This can be a drawback. This can be a big drawback. I'll tell you why. Because running the cat command multiple times can be very, very CPU intensive. It can also be memory, may not be memory intensive, but mostly CPU intensive, and it'll take more time to complete, right? There are many commands that can take variable arguments, but for cat, you can pass multiple arguments. You can say cat a.txt, b.txt, c.txt. You can pass multiple arguments. Because you can pass variable number of arguments to cat, you should be able to invoke cat command once and pass most of the files of find that found as an argument to cat. So you'll only have to invoke cat once. The best way to demonstrate this is instead of using cat command, I've created my own shell script that processes command line arguments for a demonstration. That code is very simple. I have it in my home directory here, /bash/. I call this process files.sh. It's my own script. Let's assume you can substitute this with your own custom scripts or your own programs or any Unix command. Okay. So this script does nothing but it just prints a lot of diagnostics messages. It doesn't do anything. You can see that. Obviously, it's a bash script. It's self-executable. I made it executable. And you can see echo, it prints processing files. Every time this script is called, it's going to print the process ID, $, and tells you processing files, followed by a for loop that iterates over the command line arguments passed to the shell script. Yeah, it's interesting to find out what is $@ here. Okay. If you know, just post it on comments and let me know. So I hope you know this. If you don't know, just ask me on comments. I will explain it. Okay. So that's a shell semantic. It's basically the way to process command line arguments. You can also use $*, but it's recommended not to use $*. Use $@ for processing command line arguments in a script, especially using a for loop. So I say for file in $@, I'm printing processing file in a tab. So if you basically run it like this, if you just run, it does not do anything with the file, just echoes it, okay, telling that I'm going to be processing this file, this file, this file. Instead of echo, you can put any command of your choice. This script, substitute it, right? So if I run this now, I just do a code /bash/processing files.sh, and I'll just do a.txt, b.txt, c.txt like this. The script got executed once, but it took 3 command line arguments like a.txt, b.txt, and c.txt. So it's doing processing this, processing this, processing this. Now I'm going to run this script with the exec option of find, and you can see what happens when I do that. I will find dot minus exec. I'll use maybe find dot minus type, or no, minus name, sorry, star.txt. Or I'll do one thing. There's too many files, so I'll just show you a smaller subset. One place to find out is maybe find documents. That would be a great option. I have a couple of .txt files in a document. I'll do a minus name, star.txt. Show me all files with .txt extension under the documents folder in my home directory. There are just 2 files. New file.txt, a sample text document.txt. Good enough. Now what I'm going to do, I'm just going to use minus exec, and I'm just going to use code slash bash slash process files.sh. This open close curly brace is important so that you can substitute the path as a command line argument to this script. End with a backslash semicolon. You can see the script is run twice. We'll do one thing. I'll add a couple of more text files here. There are very few text files. So in the documents folder, let me just create some dummy files with .txt extension like a.txt, touch another file.txt. I'll do a mkdir -p and test folder slash test slash temp or something, and also create a file inside it, or maybe copy one of them from here. I'll just copy maybe new file.txt to test folder test temp slash c.txt. So there are a couple of text files in this directory tree, as you can see. Now if you do a find and documents, under documents folder, show me all the text files. We'll just do a minus name star.txt here. There's so many files here. If I add this to this action where I use minus exec, and if I just use open close curly braces backslash semicolon, strange, it says some permission denied. I'm surprised to see why it shows permission denied here. Oh, okay. I'm trying to run that script. I'm trying to run all these text files as script. It's a silly mistake. I forgot to add the script, right? I just tried to tightly execute them as commands. That's why it showed permission denied. If there are 10 or 20 scripts in my folder and I want to run them, I can use this. It should have worked, right? So now I'll just do a code slash bash slash and what's it called? What's it folder name? Okay, process files.sh. I'll run this now. As you can notice here, the shell script was executed 1, 2, 3, 4, 5 times because there are 5 files. If there are 100 files, the script is executed 100 times. Not very efficient. You execute a script, it runs a bash shell, it exits, again you run it, it exits, again you run it. This is going to be CPU intensive. So if you want to make it more efficient, you have to provide a means to pass all these files as arguments to that bash script. And how do you do that? Well, the traditional way to solve this is by using a helper tool along with find command called xargs. With xargs, I'll show you an example of it. Maybe you can just use let's say I want to do something else. I'm just going to show you xargs with a different use case. Okay, I want to find out the number of lines in a couple of files. Number of lines in a couple of files in my source code folder. Let's assume code folder. Okay, so I'm looking for some files with maybe assembler code. All the assembly code. I want to find out number of lines for each of them. I can use wc-l to find out the number of lines of a list of files. I can say wc-l a.txt, b.txt, c.txt. All these are 0 bytes. Okay, a.txt is not there, so it throws no such file or directory. So I want to run this with find command. If you do this way, I can say find code and under code folder. Code is the folder I have in the current directory. I can show it to you right here. I say find code, and if I just use minus name star dot capital S, all the files that end with capital S, very likely they're all assembly programs. And I can also use minus exec, and then wc-l. I want the number of lines from these files that is found, \n. Well, there's so many files here. So wc has executed so many number of times. But if you want this wc to be executed once for all of these files, with all of these files passed an argument, or a few times, let's assume, you can use minus print, as usual, pipe, xargs, then wc-l without anything else. That's it. You can see the output reportage looks a little different because when you pass multiple arguments to wc will report number of lines, file name, number of lines, file name, number of lines, file name. It also gives a summary report indicating total number of lines amongst all the files, which you would not get if you run WC with one file, right? When you give multiple files, you also get a summary report on total number of lines of code, or total number of lines in all the files with .s extension. This could be very convenient. So this is how it is done in traditional Unixes. But this has a problem, which I will also tell you, and how to solve that. For example, if at all I want to run my script, which I created, process files.sh, for every txt file under documents. For doing that, I'll use find documents minus name star dot txt, right? So what do you see? When I use minus print pipe exargs, and now I'll run this under code /bash/ process files.sh, and that's it. If you closely observe, there's a problem. Just observe this. This is my shell script got executed once. That's good. But it took document/new as one entry, one argument. File.txt has another argument. So if I'm processing individual files, I think that document/new is one file. File.txt is another file. Document/another as another file. File.txt is another file. This is not correct, because you can see the number of entries 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You think there are 10 files, 10 different files, but in reality, there are just a handful of them. I think there's just about 4 files. So instead of using my script, if I run this with cat command, just see what happens. You got this error, right? Or you run even wc-l. Why this error came up? Why was there an error here? The reason is simply because these files had spaces inside them. You see these files? There's a space here. So when you print the output of this find command, when you run this find command and print the output, what really happened was, this is what got printed. But when you pipe this to pipe this to exargs, exargs will take all these arguments and pass them as space separated argument. I'm just going to show you how exargs is going to execute this command. I'll use exargs. I'll use echo this time. Exargs will take a command as an argument, and anything, maybe command or options, like say exargs wc, for example. Okay, wc-l. The command got executed like this. Now here's the problem. wc-l is executed with argument 1. It assumes this one file. It assumes this is another file, this as another file, this as another file. This is a problem. How are you going to solve this? Well, this is where find and exargs are coupled with an interesting option. You tell find command not to separate every line with a new line character, every entry or every record with a new line character. Print adds a new line for every path that match the criteria. But if you don't want to add a new line, but rather end with an ASCII null character, you can use -print 0. When you use -print 0 here, on the terminal, they'll all look very concatenated because the terminals normally don't print ASCII nulls. So every path is separated with an ASCII null character rather than a new line null. Now, when you feed this to exargs, you can also tell exargs to take arguments that it's getting to this pipeline as null separated, not new line separated. That's why you put a -0 switch here, followed by maybe wc-l. They're all empty files, not very useful. But I'll run my script this time. We just do code /bash/process files. So if you want to couple the output of find command with exargs for safety reasons, if there could be files or folders with spaces inside them, make sure you use -print 0, not -print. Use -print 0, pipe it to exargs -0 and the command. This will couple them correctly and works nice. So this time the arguments are tokenized by null characters. Exargs will read each of them as individual records separated by null character and then feed them as individual arguments to that target book. Otherwise, exargs will separate based on white space characters, which is space tab new line character, right? So any of these would work as word delimiters, right? So that's the reason why it works. It's actually not exargs, it's the feature with bash. Bash will tokenize and pass to exargs, and exargs will work accordingly, right? Now, this option I used is a traditional way to solve this. If you're using a modern version of Linux, the find command has an interesting switch, which sort of avoids you from having to use exargs now. So what you can do is when I use find documents minus name star.txt, and if I just do /bash/ process files.sh, and if I need to use minus exec. I forgot the minus exec switch here. Sorry, minus exec, and execute this particular script, followed by open close curly braces, which will act as a placeholder, which will be substituted with the paths being found. And I put a / semicolon. It's executing the script this many number of times. And I told you this is not very efficient, and that's why I told you how to use exargs. But right now, in modern versions of Linux, instead of using / semicolon, just end with a plus symbol. The moment you put a plus symbol, the minus exec will execute the script once and substitute multiple paths as arguments. That placeholder will be substituted with variable number of arguments based on how many paths match the criteria. So this is a more convenient way to use find command, where you don't need to worry about using exargs for most use cases, right? And yes, by the way, in bash, this works without a problem, but there are certain shells where the plus symbol would be treated like a meta character. TCSH is one example. So in such shells, the plus symbol cause a problem, put a /+ to be safe. Is a / semicolon, end with a /+. So though in bash the / is not in bash shell, / is not required. Certain shells like TCSH, you might need to prefix the plus symbol with a / because they understand that as an arithmetic operator. So you should be a little careful when you use some other shells other than bash. So this pretty much summarizes all the interesting ways to use the find command. I could go more detailed, but this video has spilled over 1.5 hours. And I'm not sure if people will watch a long video on YouTube. But yeah, if you're in here for learning something interesting, learning all these nitty-gritty details, I think this could be worth it. But there are much more I could cover. But I will try to do a part 2 of this video if you suggest me to on comments. If you're interested to know more, just post it on comments. On specific options you're looking for in find, I will try to make a video on that. But you can also look up in the man pages. The man pages elaborate. So is the info doc reader if you are looking at a more topic-wise examples and so on. You can have a look in here. There are interesting things you can do with find command. Is you can normally when you use multiple test conditions, the default is AND. You can do things like find a file name by name this, whose type is a directory, and the size is this, right? You can put minus name, minus type D, minus size. It acts as an AND operator. But sometimes you want to do a OR operator. You can use a -O switch between multiple test conditions, which will work as an OR operator. You can also use parentheses to change the order of precedence, how they work when you combine AND and OR operators. And you can also use the exclamation switch. \! Might be required for shell, and that will basically negate the condition. So yes, if you really find videos like these, longer videos, interesting and informative, and if it's entertaining also, please do hit on the like and share, and do post on comments if you have any further queries in using the find utility. In the part 2 of the video, I will try to cover other tools. Mostly I'll talk about locate and FZF, how to use them. And maybe if based on the comments, based on the feedback, I will also create another video on find if necessary for advanced use case scenarios. Thank you very much. Meet you in the next one.